To solve such linear system, the most direct way is called Gauss elimination. Okay, Gauss elimination, the Gauss elimination, and it's usually involve several operators, row operators to solve. So it's involved Gauss elimination, the Gauss elimination method is usually implements row operations in a system manner. To take the original form, and I convert that matrices, to upper triangular form. Okay, so the Gauss elimination method is basically implements many row operations in a system manner, and using such row operations to convert the original matrices to an upper triangular form. Then back substitution, evaluate the unknown solution vector of vector x. Okay, in order to solve this linear system, Gauss elimination is the most direct way, and it's implement row operations to convert the original matrices to upper matrices. Then you use the back substitution to evaluate the unknown parameters. Talking about the row operations, so elementary row operation, it can be interchange two rows. That is one of the row operations. The other one is called multiply a row by a constant, or you can say by a scalar, or you can just add a constant times one row to another. Okay. So there are three different elementary row operations. One, you can interchange two rows, or you can multiply a row by a factor, or you can just add this constant times one row to the other. Well, these row operations change the solution set of X. Okay, important question. Well, the row operation change the solution set of X. Okay, very important. Okay, will the row operation change the solution set X? No. Okay, it won't change. If that change how you solve the vector X using this row operation, right? So it won't change. Let's using notations to say what is the Gauss elimination. We can say this for to solve, basically, to solve a times x equals to b. You know what is A, you know what is B, and you are trying to get the solution set X. Then what you do is trying to construct this augmented matrices is equals to A, B, and trying to solve this matrices use row operations to convert this augment matrices to an upper triangular. Then you can use the back substitution to solve in the end. So we will make an example. For example, okay, you have a matrices. You have A is 2, 1, 9, minus 2, 3, minus 1, 4, 2, 1. That is your A 3 by 3 matrices. The X is X1, X2, X3. That is equals to 1, 2, 0. And you know that these come from 3 linear equations, right? One equation will be 2x1 plus x2 plus 9x3 equals to 1. The second equation is minus 2x1 plus 3x2 minus x3 equals to 2. The third equation is 4x1 plus 2x2 plus x3 equals to 0. So using these 3 linear equations, you are trying to find what is your vector solution set x1, x2, x3. Okay, then we will use Gauss elimination to solve it. So let's do the argument. So A augmented matrices will be equals to AB combination. So it's 2, 1, 9, minus 2, 3, minus 1, 4, 2, 1. Okay, that is U matrices A. The B will be 1, 2, 0. So this will be U matrices called argument matrices. Augmented matrix. Okay, augmented matrix. Then you are trying to use the row operations, trying to build the upper side has value. The downside will be always equals to 0. So the first row operation I will do is you use R1 plus R2. So you use the new R2 will be equals to R1 plus R2. So the you will add this R1 to the R2. That will be trying to make this part to be 0. The goal is trying to get all this value to be 0 so that you have upper matrices. Okay. So the first line didn't change to 1, 9, 1. The third line is now changed 4, 2, 1, 0. The second line will be the number plus the first line will be 0, 4, 8, 3. Okay. Then we are trying to make this number to be 0. How to make this number to be 0? So the new R3 will be equals to the current R3 minus 2 times R1. Okay, because 2 times R1 will make this number to be 0. So that after the row operation, the first line and second line is now changing. 2, 1, 9, 1, 0, 4, 8, 3. But the third line is minus 2 times the first row will be 0, 0, and that will be minus 17 and minus 2. Okay, so this is the new argument matrices after the row operations, and you can find this become upper triangular matrices after these 2 operations. Okay, then you can just use the back substitution as mentioned here, back substitution to evaluate your final solution set X. How to do the back substitution? So that here you know the minus 17x3 equals to minus 2. So your x3 equals to 2 over 17. And you also know that 4x2 plus ax3 equals to 3. And you already know what is your x3. So you will know your x2 equals to 35 divided by 68. Then you also know that 2x1 plus x2 plus 9x3 equals to 1. You already know what is ux2 and ux3, all known values. So you can easily to get ux1 will be equals to negative 39 over 136. So that is called spec substitution. You will solve the bottom vector first, and then step by step going up to the first vector. So in the end, you can get your final solution. So the solution, ux will be equals to minus 39 divided by 136, 35 divided by 68, then 2 divided by 17. Okay. It's very small here, but you can see each values here, x1, x2, x3. So this is called Gauss elimination.